Hello everyone, so we are back with Leetcode daily challenge. In today's problem we need to find the range sum of BST, that is binary search tree. In this question we are given with a binary search tree. The root of the tree is given and we are given two boundaries, the low boundary and the high boundary, and we need to find the sum of all the values of the nodes which come in between those boundaries, and that low and high value are inclusive. For example, if the low in this example given below, if the low is 7 and any node have a value of 7, then we need to consider that number too, right? So this is inclusive in nature. So it is a very much easy question. How we can solve this question? First of all, you can have any traversal. So as you know, to get the data from a binary search tree, if you are given with the root node, what you need to do, you need to iterate over each node, and that iteration is called traversal. And we have some bunch of traversal like the in order or the post order or the pre-order, right? So you can have any traversal, all will have the same time complexity. What you need to do, you need to have a simple check. The check will be like if the root dot value is less than equals to the low pointer, and root well is greater than equals, it should be greater than equals to the low pointer and it should be less than equal to the high pointer. If this condition valid, then we will add the root dot value to our sum. Root dot value, yeah, and it will be a simple function. It can be in order, post order, pre order. You can just compute the left part using recursion, compute right part, right, and at last you need to return the sum of all three, left, right, and root dot value, if the root dot value satisfies this need. So I hope this is clear. Let us try to code this solution and try to understand the logic and implementation in a bit more clear way. So we will move forward with the Leetcode. Yeah. So what we need to do, first of all we need to have some edge cases, like what if our root is null, right? So in that case we need to return a 0. So we have a edge case test, like if our root is equals to null, then we will return 0, and this will act as the boundary case or the base case for our recursive function. Then what we will do, as I said, we will have the check. So if our root dot value, root dot val, it is greater than equals to the low pointer, low boundary, and it is smaller than equals to the high. Why we are taking equals to signs? Because it is clearly given in the question, it should be inclusive in nature. If it is there, then what we need to do, we need to sum plus equals to root dot val, right? And what will be in sum, like we can take a sum variable, and as I said, like sum, let's set sum to 0, then we set to the value. Then what we will do, we will like take the left part, sum plus equals to left part. And how can we take the left part? We will pass the root dot left, right, to this function, and we will call this function recursively range sum BST. We will pass root left, yeah, then the low and the high, and similarly we will add up the right part, sum plus equals to range sum BST root right, low, and then the high part, right? So what we are doing, we are just initializing sum with 0, then we are having a check whether our condition is valid or not, whether our number, like the value of the root, is belonging to the low and high limit. If it is there, then we are adding the value to the sum, and we are then recursively calling the function for the left part of the tree, and for the right part of the tree, and at last what we will do, we will return the sum, right? Yeah, so let us try to run this code whether it works or not. Yeah, it works fine. Let us try to submit this code. Yeah, the test case passed. So let us try to discuss about the time complexity of this solution. Since we are recursively calling this function, but the recursive function, you take order traversal, the overall time complexity of order of n, where n is the number of nodes in the tree, and since we are not using any extra space, so the space complexity will be order of 1. So this is very much easy solution. I hope it is clear. Thank you for watching.